Breaking news from Starbase: SpaceX has just revolutionized Starship with upgrades that are pushing engineering limits beyond what anyone expected. The latest vehicle, dubbed Starship V2, isn't just an improvement, it's a complete transformation that's redefining our expectations for space transportation. After analyzing every technical detail released by SpaceX, we've uncovered innovations that are truly groundbreaking, from redesigned flight surfaces to experimental heat shield technology. This latest iteration packs more advanced features than even close observers anticipated. Today, we're taking you through a comprehensive breakdown of every major upgrade on Flight 7 Starship. We'll explore the enhanced propulsion systems, cutting-edge avionics, and revolutionary design changes that make this vehicle a game-changer for SpaceX's ambitious plans. Let's dive right in. Today, we're witnessing a turning point in spaceflight history with SpaceX's latest creation. The engineering breakthroughs packed into this new Starship are redefining what we thought possible in rocket design. Let's start with one of the most striking changes that caught everyone's attention at Starbase. The upper flaps of Starship have undergone a dramatic transformation. These aren't just minor tweaks. SpaceX has fundamentally reimagined how these crucial control surfaces work. The flaps are now more compact, positioned closer to the nose, and deliberately placed further from the heat shield. This isn't just about aesthetics, it's a brilliant solution to a challenge that's plagued previous flights. By moving these surfaces away from the intense heat of reentry, SpaceX has simplified one of the most complex parts of the vehicle, the dynamic seal that's been consistently damaged on earlier missions. But here's where things get really interesting. The SpaceX team has managed to increase the propellant volume by an astounding 25%. Think about that for a moment. That's a quarter more fuel in essentially the same space. This boost in capacity dramatically extends what Starship can do, though it does mean sacrificing some payload volume. But don't worry, Starship still dwarfs every other rocket when it comes to cargo space. The innovations don't stop at the surface level. SpaceX has implemented vacuum-jacketed propellant feed lines, a sophisticated solution to prevent precious fuel from boiling off during flight. This might sound like a small detail, but in the vacuum of space, every drop of propellant matters. They've also completely revamped the fuel delivery system for the Raptor vacuum engines and upgraded the propulsion avionics. These changes aren't just improvements. They're transformative upgrades that could extend Starship's operational capabilities far beyond what was previously possible. Let's talk about one of the most crucial systems on any spacecraft, the heat shield. The latest generation of tiles includes something unprecedented, a backup layer. If a tile breaks or gets damaged during the intense heat of reentry, there's now a safety net. But SpaceX isn't just playing it safe, they're pushing boundaries. On this flight, they've intentionally left some heat shield sections exposed as a stress test. Even more intriguing are the experimental metal heat shield tiles, including one with active cooling technology. This active cooling system is particularly fascinating. While SpaceX hasn't revealed all the details, we could be looking at either transpirational cooling, where tiny holes in the metal release propellant to create a protective boundary layer, or regenerative cooling, similar to what keeps rocket engines from melting. Either way, this is cutting-edge technology that could revolutionize how we handle the extreme temperatures of atmospheric reentry. The avionics system has received a complete overhaul that's nothing short of revolutionary. The new flight computer isn't just more powerful, it's part of a sophisticated network that includes integrated Starlink connectivity, enhanced navigation systems, and redundant RF communications. They've added new inertial navigation capabilities, star trackers, and smart batteries. This isn't just an upgrade, it's a complete reimagining of how a spacecraft thinks and communicates. Speaking of communication, SpaceX has outdone themselves with the camera systems. The new Starship carries over 30 high-definition cameras, more than any launch vehicle in history. Thanks to Starlink integration, these cameras can stream at an unprecedented 120 megabits per second. This isn't just about giving us amazing views, it's about gathering crucial data during every phase of flight. Flight 7 will also mark the first test of Starlink mass simulators in flight. 10 dummy satellites have been loaded onto Starship, adding another layer of complexity to this mission. While these simulators won't be deployed into orbit, They'll burn up during re-entry along with Starship. They're crucial for testing payload deployment mechanisms and understanding how the vehicle handles with cargo. The Raptor relight test planned for this mission is particularly critical. Successfully relighting engines in space isn't just about extending mission capabilities, it's about safety. A controlled deorbit is essential to ensure that a vehicle as massive as Starship doesn't pose any risk to populated areas during re-entry. This test will provide vital data about the reliability of these systems. SpaceX has also made significant structural improvements based on data from Flight 6. After observing deformation during re-entry, engineers identified and reinforced key stress points. They're not just fixing problems, they're deliberately testing limits to understand exactly what Starship can handle. This approach of pushing boundaries during test flights is crucial for developing a robust, reliable vehicle. In a fascinating development, Flight 7's Starship, officially Starship 33, includes non-structural versions of the catch fittings. These components, designed to eventually enable the vehicle's recovery, will undergo their first thermal performance test. If they survive re-entry intact, it could mark a crucial step toward the holy grail of full reusability. Speaking of reusability, Flight 7 marks another historic first, the reuse of a Raptor engine. Specifically, their flying Raptor 314, which previously flew on Flight 5. This engine's performance could pave the way for regular booster reuse, potentially as soon as this year. The upgrades to the tower and chopsticks are equally significant. After the sensors were damaged during Flight 6's catch attempt, SpaceX has implemented new protections that should give us a better chance of seeing a successful booster catch this time around. The sheer number of innovations packed into this vehicle is staggering. Each upgrade represents countless hours of engineering work, problem solving, and creative thinking. From the redesigned flaps to the experimental heat shield tiles, from the enhanced avionics to the reused Raptor engine, every change brings us closer to achieving regular, reliable access to space. What makes these developments particularly exciting is how they build on lessons learned from previous flights. SpaceX isn't just making changes for the sake of change, they're systematically addressing challenges, testing new solutions, and pushing the boundaries of what's possible in rocket design. This iterative approach, combined with their willingness to take calculated risks during test flights, is accelerating the pace of innovation in ways we've never seen before in the space industry. Flight 7 represents more than just another test launch. It's a testament to rapid innovation in spaceflight. Every upgrade we've discussed today, from the redesigned flaps to the experimental heat shield tiles, brings us closer to making space travel as routine as air travel. The data gathered from this flight will be crucial for future Starship missions. As we watch these groundbreaking technologies being tested, we're witnessing the evolution of space transportation in real time. Stay connected with our channel for comprehensive coverage of Flight 7's launch and all future Starship developments. Your engagement helps us bring these exciting technological breakthroughs to a wider audience. Hit that subscribe button to join our growing community of space enthusiasts, drop a comment sharing your thoughts on these incredible upgrades, and don't forget to like this video if you found it informative. For the latest updates on Starship's development and other SpaceX news, make sure you're following Elon Musk 24 hours. Together, we're tracking humanity's next giant leap into the final frontier. Keep looking up. There's never been a more exciting time in spaceflight history. In the pre-dawn hours of a January morning, two titans of the space industry are about to write history. After 25 years of development, Blue Origin stands at the threshold of its most ambitious mission yet, the first orbital flight of New Glenn. But there's more to this story than meets the eye. As SpaceX prepares for Starship's Flight 7 on January 13th, Blue Origin initially set their launch for January 10th, only to shift it to January 12th. The official reason? Rough Atlantic seas where their booster is meant to land. But the timing raises eyebrows. It's as if Jeff Bezos has chosen this moment to finally answer Elon Musk's advances in the space race. This isn't just another rocket launch. For the first time, Blue Origin is attempting something that even SpaceX needed multiple tries to perfect, landing their orbital-class booster on its very first mission. Out in the Atlantic, their recovery vessel Jacqueline, a sister to SpaceX's drone ships, already waits at the designated landing zone. The stakes couldn't be higher. Success would catapult Blue Origin from a company known for suborbital tourist flights to a serious contender in the orbital launch market. Failure would raise hard questions about the company's ability to compete in an increasingly crowded field. The engineering behind this attempt is fascinating. New Glenn isn't just big, it's revolutionary. With 7 reusable BE-4 engines generating over 17,000 kilonewtons of thrust, sophisticated aerodynamic surfaces, and a landing system designed for at least 25 reuses, this rocket represents the culmination of everything Blue Origin has learned over a quarter century. Welcome to Elon Musk 24 Hours, where we bring you the latest in space innovation and technology. Let's dive right in. 2025 marks a pivotal moment in SpaceX's journey. As we approach Flight 7, the anticipation at Starbase is palpable. Engineers move with renewed purpose around Starship S-33 and Booster B-14, but their attention keeps returning to one critical component that could make or break this mission: the revolutionary V2 flap system. The story of these flaps is more than just technical innovation. It's a testament to SpaceX's relentless pursuit of perfection. Back in 2021, even Elon Musk knew something wasn't right. "The old design was killing me," he confessed, highlighting how the original flaps were pushing the nose backward during the most critical phase of flight. It was like trying to swim upstream with weights tied to your arms. Possible, but far from ideal. Those early V1 flaps tell a story of both triumph and tribulation. Symmetrically placed at 180 degrees around the nose cone, they were massive, heavy structures that looked impressive but harbored a fatal flaw. During re-entry, as temperatures soared to a blistering 1,500 degrees Celsius, hot enough to turn sand into glass, these flaps became Starship's Achilles heel. Flight 4 brought this reality crashing home. As Starship plunged through the atmosphere, the forward flaps began to fail. Those watching the live stream held their breath as the flaps, glowing from intense heat, threatened to tear away completely. While the spacecraft survived, the message was clear. Evolution wasn't just an option, it was a necessity. The transition to V2 flaps represents more than just an upgrade. It's a complete reimagining of how a spacecraft should control its descent. The new forward flaps are notably smaller, with a sleeker profile that slices through the atmosphere like a hot knife through butter. But size isn't the only change. SpaceX engineers made a bold decision to break from tradition, repositioning the flaps at an angle between 120 to 140 degrees on the leeward side of the ship. This asymmetrical positioning might seem counterintuitive, but it's pure genius in action. By moving the flaps more toward the leeward side and closer to the vehicle's tip, SpaceX has created a design that naturally shields these crucial components from the brutal forces of re-entry. It's like a boxer learning to roll with the punches instead of taking them head-on. The gaps that once existed between the flaps and the ship's body, small but problematic weak points that allowed superheated plasma to wreak havoc, have been eliminated. The new construction creates a unified structure that's more resilient and more reliable. These aren't just improvements. They're solutions born from the school of hard knocks. But perhaps the most significant advancement lies in how these changes work together. The reduced mass of the flaps, combined with their optimized positioning, has created a cascading effect of benefits. The lighter weight means better fuel efficiency. The improved positioning enables more precise control during landing. Even the manufacturing process has been simplified, making these advanced components easier to produce and maintain. The implications for Flight 7 are profound. As S-33 prepares to carry its payload of simulated Starlink satellites, these redesigned flaps will play a crucial role in every phase of the mission. During ascent, their streamlined profile will reduce drag, helping Starship punch through the atmosphere more efficiently. In space, their precise control will facilitate the first-ever payload deployment from a Starship vehicle, a historic moment in the making. But the real test comes during re-entry. This is where previous designs face their greatest challenges and where the V2 flaps are expected to shine. The new positioning will help protect them from the intense heat, while their optimized shape will provide the control needed for a controlled descent. SpaceX isn't just aiming for survival, they're aiming for perfection. The ocean landing planned for Flight 7 will push these new flaps to their limits. Unlike previous tests, this mission may incorporate steeper angles of attack and more complex maneuvers. It's like a test pilot putting a new aircraft through its paces,